Welcome to solverfy.
All right, in question 30, we are comparing carbon tetrachloride. Let me get my pointer up here. Carbon tetrachloride, which is going to be CCl4, and we're comparing that to chloroform, which is CHCl3. So the question is telling us that the carbon tetrachloride has a normal boiling point equal to 77 degrees Celsius, and chloroform has a normal boiling point of 61 degrees Celsius. So right away we can see that chloroform has the higher boiling point, therefore must have the stronger intermolecular forces. So they're asking us to figure out which one of the following reasons could be the reasoning behind why carbon tetrachloride has the higher boiling point. The first one says chloroform, which is here, can hydrogen bond, but carbon tetrachloride cannot. And that is false. The hydrogen here is bonded to a carbon, and in order for something to form a hydrogen bond, you need to have a hydrogen that's bonded either to an F, O, or N, and not a carbon. So this cannot hydrogen bond, so that cannot be the reason behind why this has the higher boiling point. The next possibility says that carbon tetrachloride has a larger dipole moment than chloroform. So carbon tetrachloride is going to have 4 chlorines coming off. It's going to be a tetrahedral shape, and because all of these are chlorines on the outside, the vectors, the difference in electronegativity between chlorine and carbon is the same, therefore all the vector lengths are the same, and the tetrahedral shape is a symmetric shape, therefore the vectors will cancel, and this is a nonpolar molecule. So if it's nonpolar, it certainly cannot have a larger dipole moment. It does not have a dipole moment because it is nonpolar. So that cannot be a reason. Part C says that carbon tetrachloride is more polarizable. So polarizable has to do with when you're looking at your London dispersion forces and how much the electron clouds can be polarized, can be shifted. And that basically has to do with the greater the molecular mass, then in general, the greater the electron cloud and the more polarizable. This one has 4 chlorines attached to the carbon versus only 3 and a small hydrogen. So yes, this one is going to have a larger molecular mass. It's going to therefore have a larger electron cloud and be more polarizable. So part C is definitely a reason. Because it's more polarizable, it have stronger London dispersion forces and therefore a higher boiling point. So this is definitely a reason that this molecule could have the higher boiling point.